whenever there is one arbitrary constant present, you have to differentiate one time. Whenever there are two arbitrary constants, let's say present, you have to differentiate twice, and so on. If there are three arbitrary constants, you have to differentiate three times. Take x square common. So we get x square 1 minus sine square x. Okay, on the right hand side, there is just y. So there is no x term at all. But in our left hand side, there is this x term. So if we want to get the right hand side, we need to eliminate that x term anyhow. Okay, and solution can be of two types. It can be a general solution. A general solution is a solution which involves one or more arbitrary constants. And a particular solution is a solution which doesn't have any arbitrary constant. Now let's move on to next exercise where we learn about forming of a differential equation. In this chapter, we just deal with two type of problems, which is on forming of a differential equation and solving of a differential equation. Okay, we already studied what the distinction is. I would like to give you a quick recap. If we have an equation in x and y, if I take derivative of that equation, I get a differential equation. Okay, if I take derivative of an equation in x and y, I get a differential equation, and that process of taking derivative is called forming of a differential equation. If I have a differential equation, if I convert that equation into the equation of x and y, I will have to integrate that. Okay, I will have to integrate that differential equation to get the equation in x and y, and that process of integrating is called as solving of a differential equation. We have already studied that. This was just a quick recap. Okay, now let's start with the questions based on forming of a differential equation. Now let's see how do you find out whether the question that is given to you is based on either forming or whether it is solving. Let's see how to find out. In case of forming of a differential equation, they will give you an equation in x and y. Always they have to give you an equation in x and y, and they will give you a differential equation, and they will tell you that verify that the given equation in x and y is a solution of this differential equation. Okay, so whenever they tell you that verify that this equation in x and y is a solution of this differential equation, you immediately know that you have to differentiate or take derivative of that equation in x and y to prove that this equation is true. If you notice here, it is y double dash. So we'll have to differentiate it two times in order to prove this. Okay, so let's start by differentiating with respect to x. Differentiate with respect to x. The derivative of y is dy by dx with respect to x is equal to derivative of e to the power x with respect to x is e to the power x plus derivative of 1 with respect to x is 0. All right. So therefore we get dy by dx is equal to e to the power x. All right. Since there is y double dash here as well, let's differentiate it one more time. Let's differentiate one more time with respect to x. So therefore we get d2y by dx square, derivative of dy by dx with respect to x is d2y by dx square is equal to, again, derivative of e to the power x with respect to x is again e to the power x. Okay, note that dy by dx is nothing but y dash. Okay, so y dash is e to the power x, and here this d2y by dx square is nothing but y double dash is also e to the power x. Okay, now we need to prove that this equation is true. In other words, we have to prove that this equation in x and y is the solution of this differential equation. Okay, so in order to prove that, let's start with LHS. So if we start with LHS, so LHS is y double dash minus y dash. Okay, so that's my LHS. Now the y double dash is e to the power x minus y dash is also e to the power x. Okay, so e to the power x minus e to the power x, which is 0, that is equal to my RHS. Hence, it's proved that LHS is equal to RHS. Hence, we were able to prove that this equation on the left side here is a solution of this differential equation. All right, let's start with this example. Y is equal to x square plus 2x plus c. This is the equation in x and y that is given to me. And I need to prove that this equation in x and y is a solution of this differential equation y dash minus 2x minus 2 is equal to 0. So in other words, I need to take derivative of this differential equation and get this differential equation which is present here. Okay. Now, a few things to note here. One is, notice that there is one arbitrary constant here. Arbitrary constant. C is an arbitrary constant. Notice that there is one arbitrary constant present. Now, this is an important thing to note, that whenever there is one arbitrary constant present, you have to differentiate one time. Whenever there are two arbitrary constants, let's say present, you have to differentiate twice, and so on. If there are three arbitrary constants, you have to differentiate three times. So in other words, there is important note that I would like you students to remember, that number of arbitrary constants present. In this case, there is just one, so you have to differentiate once. Always remember, number of arbitrary constants in the differential equation is the number of times you will take derivative. Okay. uh, that is how you actually see how many times to differentiate. Okay, because it's very important to know, if this equation was not given to you, here you can see that there is y dash. So by looking at y dash also, you can confirm that okay, you have to differentiate one time. Okay, but what if this equation was not given to you and only this equation was given to you? Okay, so how do you know that how many times you have to differentiate? So you look at the number of arbitrary constants. Since there is one arbitrary constant, you have to differentiate one time. Okay, there is a very important note that I would like you students to remember. And also remember that final differential equation doesn't have any arbitrary constants. This differential equation doesn't have any arbitrary constant, because when you take derivative, you have to make sure that arbitrary constant becomes zero when you take derivative. Okay, so that's very important key notes to remember before we actually start solving this example. Okay. Now that we understand those important notes, let's start solving this example, which is y is equal to x squared plus 2x plus c, where c is the arbitrary constant. And we need to prove that this equation in x and y is the solution of this differential equation on the right hand side. Okay, so we have to take derivative of this equation in x and y and get this differential equation. Okay. Uh, Note that there is one y dash. That means we have to just differentiate one time. Okay. If this equation was not given to you, we still know now that we have to just differentiate one time, because there is just one arbitrary constant present. Okay. All right. Now let's differentiate that equation with respect to x. We differentiate. Let's differentiate with respect to x on both the sides. Okay. So we get the derivative of y with respect to x is dy by dx, okay, is equal to x square. The derivative of x square with respect to x is 2x, plus derivative of 2x with respect to x is 2, plus derivative of c with respect to x is 0. Okay, so therefore the dy by dx term is nothing but y dash. So the y dash is, we get is 2x plus 2. So we have y dash. Now that we have y dash, we can actually substitute everything in the left hand side. Okay, so our left hand side is y dash minus 2x minus 2. Okay, so let's see what do we get. Our left hand side, our LHS is y dash minus 2x minus 2, which is equal to, now that we know y dash is 2x plus 2. This is my y dash that I found out. Then I have minus 2x and minus 2. If you notice, the things get cancelled here. 2x and 2x get cancelled. 2 and 2 get cancelled. So I am left with 0, which is my right hand side. Therefore, left hand side is equal to right hand side. Therefore, we are able to prove that this equation here, the equation y is equal to x square plus 2x plus c, is a solution of this differential equation. In exam, you have to actually write that statement, that therefore y is equal to y is equal to 2 sorry y is equal to x square plus 2x plus c, y is equal to x square plus 2x plus c is a solution is a solution of differential equation is a solution of differential equation y dash minus 2x minus 2 is equal to 0. And that is our final result. I hope it makes sense so far. Let's look at next example, which is y is equal to cos x plus c. Very simple example. Again, note that there is just one arbitrary constant. So you just have to take derivative one time, which is the first order derivative. Okay. You can also see that here that there is just y dash, which also confirms that you just have to take derivative one time. Okay. It's very easy. Let's take derivative. So we say differentiate with respect to x, differentiate with respect to x. Therefore, we get dy by dx. The derivative of cos x is minus sine x plus the derivative of that constant c is 0. Therefore, we know this dy by dx is nothing but y dash. So we get y dash is equal to minus sine x. You can either start with your left hand side, or here I can directly see that if you just take that minus sine x on the other side of equation, you directly get y dash plus sine x is equal to 0, which is the differential equation we are looking for. Okay, hence we proved that this differential or this equation in x and y is the solution of this differential equation, because the moment we take the derivative of this equation in x and y, we get this differential equation that they are asking us. Okay, so hence it is proved that therefore y equal to cos x plus c is a solution of differential equation of a differential equation y dash plus sine x is equal to 0. That's what you have to write in exam to get full marks. All right, let's move to the next example, which is y is equal to square root of 1 plus x square. And we need to prove that this equation in x and y is the solution of this differential equation on right hand side. We notice that there is y dash, which is dy by dx. So we need to differentiate this equation one time to get this differential equation. Okay. Let's start by differentiating this equation with respect to x. Differentiate with respect to x, and we get the derivative of y with respect to x is dy by dx is equal to, now notice that this is just like square root of u. We have to use chain rule in derivatives. So this is just like square root of u. We know that in derivatives, if y is equal to square root of x, the derivative of square root of x with respect to x is 1 upon 2 root x. We know this already. Now, if instead of x, if it was u, if instead of x, it was, let's say, u, the derivative of y with respect to x. Now, the chain rule in derivative says you can apply the same formula. You can apply the same formula. So, if derivative of square root of x is 1 upon 2 root of x, derivative of square root of u is 1 upon 2 root u, you just have to multiply by du by dx. You just have to multiply by that extra term, which is derivative of u with respect to x. Okay. So, notice that this is just like u. Okay. So, we can apply the chain rule here and say that the derivative of this square root of u is 1 upon 2 root u, which is 1 plus x square. We just apply this formula, okay? 1 upon 2 root u into du by dx, which is d by dx of 1 plus x square. I hope that makes sense. This is just chain rule in derivatives, okay? So that will be 1 upon 2 square root of 1 plus x square. Now, derivative of 1 plus x square, derivative of 1 is 0 and derivative of x square is 2x. Okay, I hope that makes sense. Now, this 2 and 2 will get cancelled and we get x divided by square root of 1 plus x square, and this is dy by dx, which I can write this as y dash, okay, because dy by dx is just represented as y dash. Now I need to prove that this equation is true. Okay. You can either start with LHS. So LHS is just your y dash. Okay. Notice that here it is x into y divided by 1 plus x square. And here it is square root of 1 plus x square. Okay. Versus here on the right hand side, you have 1 plus x squared. So I understand if I want 1 plus x square here, I need to multiply and divide by square root of 1 plus x square on the right hand side. I have to multiply and divide by square root of 1 plus x squared. Why do I do that? Because I see here that there is 1 plus x square in the denominator and I have square root of 1 plus x square. So if I want to get 1 plus x square, I'll have to multiply and divide by square root of 1 plus x square. So this times this will give you x times square root of 1 plus x square. So square root of 1 plus x square multiplied by square root of 1 plus x square is nothing but 1 plus x square. And that is your y dash. Notice that this square root of 1 plus x square is nothing but your original equation, which is y. So we can easily replace this square root of 1 plus x square with your y, which is your original equation. So therefore we can say here, since y is equal to square root of 1 plus x square, therefore you can just replace the square root of 1 plus x square with y. So you get y dash is equal to x times y divided by 1 plus x square, which is the differential equation that we are looking for. Therefore, we can say that y is equal to square root of 1 plus x square is a solution is a solution of differential equation. I'll just write in short form DE, which means differential equation y dash is equal to x times y upon 1 plus x square. That's what you have to write in exam in order to get full marks. Okay. I hope that makes sense so far. All right. The next example says y is equal to capital AX. And so prove that this equation in x and y is a solution of this differential equation. Note that there is this a, which is your arbitrary constant, and notice that there is just one arbitrary constant. Hence, we know that we have to differentiate now just one time. And that is also confirmed from here that since it is y dash, which is dy by dx, you just have to differentiate once in order to get that differential equation. Okay. So let's start by differentiating with respect to x. Differentiating with respect to x, we differentiate y with respect to x. Derivative of y with respect to x is dy by dx is equal to, now note that a is a constant, we can just write it the way it is because it's in multiplication, and derivative of x is nothing but 1. So therefore we get dy by dx is nothing but y dash. So we get y dash is equal to a. Okay. Now, in order to get this differential equation or prove that this differential equation is true, we can start with your LHS. In this case, the LHS is x times y dash. Okay. Now, it's x times y dash is nothing but a. Okay. So we get x times a. But we need to say that there is y here. In the RHS, we need y. Notice that x times a is a times x is nothing but y. Okay. So this x times a is nothing but y. So we can say this is equal to y, and that is equal to RHS. Here we can say since y is equal to ax, given equation, given equation. Okay. Because x times a times x is nothing but y. Okay. So you can replace that x times a with y, and that you get RHS. Therefore, we can say that this equation in x and y is a solution of this differential equation. So we can write that. So therefore, y is equal to ax, which is the equation that is given to us, is a solution, of differential equation x of the differential equation x y dash is equal to y. So we write that as x y dash is equal to y. This is what you have to write in exam in order to get full marks. Okay. All right, let's look at this next example, which is y is equal to x into sine x, and we need to prove that this equation, this equation in x and y, is a solution of this differential equation. Okay, we see there is one y dash term, so we'll have to differentiate one time again. So we say differentiate this equation with respect to x. Now let's differentiate this with respect to x. Derivative of y with respect to x is dy by dx is equal to, now this is product rule or UV rule, okay? Product rule in derivatives. We know that the product rule in derivatives, if it is d by dx of u into v, the product rule or the UV rule in derivatives is u into derivative of v plus v into derivative of u, okay? That's the product rule or UV rule in derivative. So we get dy by dx as, we keep u the way it is and we take derivative of sine x. So we get d by dx of sine x plus, let me remove this formula, plus we keep sine x the way it is. We keep sine x the way it is. And then we take derivative of x. So we get d by dx of x. Okay, I hope that makes sense. It's just like keep x the way it is, take derivative of sine x, then keep sine x the way it is and take derivative of x. Okay, therefore we get x times d by dx of sine x is cos x plus sine x d by dx of x. So derivative of x with respect to x is 1. So therefore dy by dx here on the left hand side is nothing but y dash. So we get y dash as x times cos x plus sine x. X times cos x plus sine x. That is our y dash that we have so far. Okay. Now, in order to get this or prove that this differential equation is true, we need to start with LHS. Okay, we can start with either LHS or we can start with RHS. Either way, let's start with LHS. Okay, so we say LHS is equal to x times y dash. Okay, so that gives us x times, we calculated y dash, which is x cos x plus sine x. Okay, so that will give you, just multiply this x inside. So we get x square cos x times x is x square, plus x times sine x. Okay, now it looks like it's no near to this RHS. Okay, so in order to get both RHS and LHS same, I think we'll have to simplify right hand side as well. Okay, so let's simplify right hand side as well. So let's start with right hand side as well. So our right hand side is y plus x square root of x square plus y square. So we write y plus x square root of x square minus y square. X square minus y square. Notice that in LHS, there are all the x terms. There is no y term at all. Okay. There is no y term at all in your LHS. So that's what we'll do here. We'll try to replace that y with the given equation. Since we know the given equation, y is equal to x sine x, that's what we'll try to do. We'll try to replace that y with the given equation, which is x into sine x. So we'll convert this RHS also in terms of x, just like LHS. So plus x square root of x square minus y is nothing but x into sine x, the whole squared. Okay, I hope that makes sense. Let us simplify this a little bit. So we get x sine x. Notice that we already got x sine x, which is present here. Okay, plus x square root of x square minus, now this square can be given to x and sine x, so we get x square sine square x. I hope that makes sense so far. Now this is equal to x sine x plus x square root of. Now from here and here, take x square common. So we get x square 1 minus sine square x. Okay. Now we know that 1 minus sine square x is nothing but cos square x. By identity, trigonometric identity, we know 1 minus sine square x is nothing but cos square x. So we get x sine x plus x square root of x square times 1 minus sine square x is cos square x. Okay. Now that will give you x sine x plus x. Now this square root and these two squares will get cancelled. Okay. So x square and square root of x square is nothing but x. Square root of cos square x is nothing but cos x. Okay. Now that x times x will become x square. So you will get x sine x plus x squared cos x. Notice that this is what was my left hand side turned out to be. Okay. So this is equal to your left hand side. Therefore, we can say that y is equal to x times sine x, which was your original equation in x and y is equal to x sine x, is a solution of this differential equation. So y is equal to x sine x is solution of the differential equation x times y dash is equal to, let's see what was the equation again, y plus x square root of x square minus y square. Okay, so y plus x square root of x squared minus y square, and that is how you will represent your final result. All right, let's look at this next example, which is xy is equal to log y plus c. Note that this c is an arbitrary constant. And since there is just one arbitrary constant in this equation in x and y, we just have to differentiate this once in order to get this differential equation. Okay. And that is also confirmed with this y dash. Since there is just y dash, we just have to differentiate this once. Okay. Now let's differentiate this with respect to x. This is also implicit function. Okay. Let's differentiate this with respect to x. Okay. Now we'll have to differentiate both the sides. Note that the left hand side is also x into y. So we'll have to use the UV rule or the product rule in integration, which is u. So keep x the way it is and take derivative of y, which is dy by dx, plus keep y the way it is and take derivative of x with respect to x, d by dx of x. That's just the product rule or the UV rule in in the derivatives. Okay, so keep x the way it is, take derivative of y, keep y the way it is and take derivative of x. Okay, is equal to derivative of log y with respect to x. We know that derivative of log x with respect to x is 1 over x. If it is log u, so if instead of x there is u, it is 1 over u du by dx. Okay, 1 over u du by dx. So in this case, and that's the chain rule in derivatives. Okay, so in this case, we have the derivative of log y is 1 over y into dy by dx. Okay, because the derivative of log y is 1 over y dy by dx by chain rule, plus derivative of that constant c or the arbitrary constant c is 0. Okay, I hope that makes sense. Let us simplify this a little bit. So we get x, we know dy by dx is nothing but y dash. So x y dash plus y, derivative of x with respect to x is nothing but 1, is equal to 1 over y, and again here dy by dx is nothing but y dash. Okay, now in order to find y dash or get the y dash, let us take this y dash. So there are two y dash terms. There is this y dash term and there is this y dash term. Let's take those y dash terms together. So bring this on the left hand side, bring this term on the left hand side along with this y dash. So we get therefore x y dash minus y dash divided by y, because this y dash times 1 is y dash, so we get y dash divided by y, and bring that y dash divided by y on the left hand side, so we get minus y dash divided by y. Now bring this y on the right hand side, so we get minus y. Okay, I hope that makes sense so far. Now in order to find y dash, let's take y dash common here. Okay, we can take y dash common, so we get y dash, and we are left with x in the first term. If we take y dash common, we get x minus, if we take y dash common from here, we got 1 over y is equal to minus y. I hope that makes sense so far. Okay, so therefore let us simplify this expression a little bit. Cross multiply, so we get y dash, so we get x times y minus 1 divided by y. Okay, x times y minus 1 divided by y is equal to minus y. Okay, I hope that makes sense so far. We are almost close to the result that we need. Now we can cross multiply again. So this y, in order to get this y dash, the value of this y dash, this y can be multiplied here, this y, and this xy minus 1 can go in the denominator. So therefore, we get y dash is equal to, this y can go here, so minus y square. Y times y is y square, divided by this xy minus 1 can come in the denominator. That will give you xy minus 1. Now let's see what is the difference between this and what we need to prove. So that's what we have. And in our differential equation that we need to prove, it is this one. The only difference is there is no negative here, and that negative is multiplied in the denominator. Let's see what do I mean by that. So this negative in the numerator, let's take it in the denominator. So we get therefore y dash is equal to y square. That negative just multiplied in the denominator, xy minus 1. So therefore we get y dash is equal to y square divided by, now minus times, or minus 1 times xy is minus xy, minus 1 times minus 1 is plus 1. Okay, so therefore y dash is equal to y square upon, this is 1 minus xy. That is what we needed to prove. Therefore, we can say that xy is equal to log y plus c. Therefore, we can say, therefore, xy is equal to log y plus c is a solution of differential equation y dash is equal to y square upon 1 minus xy. Okay, and that is our final result. All right, let's look at next example. Y minus cos y is equal to x. We need to prove that this equation in x and y is solution of this differential equation. Notice that there is just one y dash, so we'll just have to differentiate this one time. Let us differentiate this equation in x and y with respect to x. Okay, let's differentiate this with respect to x, and let's see what do we get. We know the derivative of y with respect to x is dy by dx minus derivative of cos y with respect to x. We know the derivative of cos x is minus sin x. Therefore, the derivative of cos y is minus sin y into derivative of y with respect to x by chain rule. Okay, because this is not cos x, this is like cos u. So chain rule says the derivative of cos u is minus sin u into du by dx. Okay, that's just chain rule in derivatives, is equal to derivative of x with respect to x is 1. Okay, therefore dy by dx is nothing but y dash, minus and minus will become plus sin y into, again dy by dx is nothing but y dash is equal to 1. Okay, I hope that makes sense so far. Now let's try to find the value of y dash first. Okay, so we can take y dash and y dash common from here. So we get y dash 1 plus sine y. If you take y dash common, you will be left with 1 in this expression. And if you take y dash common from here, you will be left with sine y is equal to 1. Okay, now therefore we get y dash is equal to, if you want to find y dash, you can take this term in the denominator. Okay, so we get y dash is equal to 1 divided by this 1 plus sine y can be taken in the denominator. We get 1 plus sine y. Okay, so that's the value of y dash that we get so far. I hope that makes sense. Now let's start with your LHS to see if we can get the RHS. Okay, now that we have the value of y dash, let us start with your left hand side. Let's start with the left hand side. So left hand side is y sine y plus cos y plus x, y sine y plus cos y plus x times y dash. Notice that on the right hand side of this differential equation, there is just y. Okay, on the right hand side, there is just y. So there is no x term at all. But in our left hand side, there is this x term. So if we want to get the right hand side, we need to eliminate that x term anyhow. So in order to eliminate that x term, if you go to your original equation, you see that there is value of x already given. The value of x is y minus cos y. Okay, the value of x is y minus cos y. So the first thing in order to eliminate x from here is I will say y sine y plus cos y plus x can be written as minus y minus cos y, y minus cos y. That was your value of x from your given equation, y minus cos y. Okay, so that's your value of x from your given equation and times y dash. Immediately you can see that cos y and cos y can get cancelled. So you are left with y sine y plus y, and you can substitute the value of y dash, which is 1 over this y dash. You can say y dash is 1 over 1 plus sine y. Okay, we can simplify this a little bit. If you notice here, you can take y common from these two terms. If you take y common from those two terms, you will be left with, in this term, you will be left with sine y, plus in this term, you will be left with 1. Okay, if you take y common, you will be left with sine y plus 1, and you have 1 over 1 plus sine y in the denominator. Now, if you notice this numerator and denominator, 1 plus sine y and 1 plus sine y, they can get cancelled. Okay, now that is giving you y, which is nothing but your right hand side. Therefore, we can say left hand side is equal to right hand side, and therefore we can say y minus cos y is equal to x is a solution of differential equation of the differential equation y sine y plus cos y plus x of the differential equation y sine y plus cos y plus x times y dash is equal to y. Okay, y sine y plus cos y plus x times y dash is equal to y. Hence, we prove that this equation in x and y is a solution of this differential equation, which is what you have to write in your exam in order to get full marks. All right, the next example, we have x plus y is equal to tan inverse of y, and we need to prove that this equation in x and y is a solution of this differential equation. Okay, notice that there is just one y dash, which is dy by dx. So we just have to differentiate this one time. So we start by differentiating with respect to x. Let's differentiate this with respect to x. So derivative of x with respect to x is 1 plus derivative of y with respect to x is dy by dx is equal to the derivative of tan inverse y with respect to x is 1 upon 1 plus y square times derivative of y with respect to x, which is dy by dx by chain rule. Okay, because we know that derivative of tan inverse x is 1 upon 1 plus x square. But if it was instead of x, derivative of tan inverse u, the derivative is 1 over 1 plus u square into du by dx. That is the chain rule. Chain rule says you have to always multiply by the derivative of u with respect to x. In this case, instead of u, I have y. So I multiplied that by dy by dx. Okay. Now we know that dy by dx is nothing but y dash. So we get 1 plus y dash is equal to 1 over 1 plus y square into y dash. So I replace that dy by dx and this dy by dx with y square. Now I see this equation is very simple to get. Just multiply this entire equation by 1 plus y square. If you multiply this entire equation by 1 plus y square to eliminate this denominator, we almost have this equation. Just multiply both sides. Multiply both sides by 1 plus y square. Multiply by 1 plus y square. So we get, therefore, multiply this by 1 plus y square. So we get 1 plus y square multiplied by 1 plus y dash is equal to, if you multiply this by 1 plus y square, we get y dash because 1 plus y square and 1 plus y square will get cancelled. Okay, I hope that makes sense. Now just open this bracket up. If you open that bracket, you will get 1 times 1 is 1, 1 times y dash is y dash, y squared times 1 is y squared times y dash is y square y dash is equal to y dash. Okay, very simple. Now this y dash and y dash on both the sides will get cancelled. Therefore, if you see, we already got this. Okay, so we get y squared y dash plus y square plus 1 is equal to 0. That is what we needed to prove. Okay, therefore we can say that therefore x plus y is equal to tan inverse y, the given equation. Therefore we can say given equation is a solution. Given equation is a solution of differential equation y squared y dash plus y dash, sorry, plus y squared plus 1 is equal to 0. Therefore, we can say this equation in x and y is a solution of a differential equation y squared y dash plus y squared plus 1 is equal to 0, and that is your final result. I hope that makes sense. All right, let's see this example, which is y is equal to square root of a square minus x square. We need to prove that this equation in xy is the solution of this differential equation here. Okay. Since we see there is just one dy by dx or one derivative term, we just have to differentiate this once. So let us differentiate this equation with respect to x. Therefore, we get derivative of y with respect to x is dy by dx is equal to, now this is like square root of u. We know that derivative of d by dx of square root of x is 1 upon 2 root x. Now if instead of x, if it was u, so derivative of root u is also 1 upon 2 root u, but you have to multiply by an extra term which is du by dx. Okay, that's the chain rule in derivatives. So therefore we get derivative of this is just like u. Square root of u is 1 upon 2 root u. So 1 upon 2 root a square minus x square into d by dx of u, or derivative of u with respect to x. So we get d by dx of a square minus x square. I hope that makes sense so far. Let us simplify this a little bit. So we get 1 upon 2 root a square minus x square. Now, derivative of a square with respect to x is 0 because a square is constant, minus derivative of x square with respect to x is 2x. Okay. So therefore, we get 1 upon 2 root a square minus x square, and this is 0 minus 2x is minus 2x. Now this 2 and 2 will get cancelled in the numerator and the denominator, and you will be left with 1 times minus x is minus x upon square root of a square minus x square. Okay, I hope that makes sense so far. In this case, it looks like it is best to start with your left hand side in order to prove that right hand side is 0. Okay, you can also prove directly from here, but I think let's anyway go with the left hand side. So let's start with left hand side. The left hand side is x plus y dy by dx. Note that this was dy by dx. Okay, so this was your dy by dx. Let us substitute the value of dy by dx here. So we get, note that if we substitute dy by dx here, which is this term, this will be in terms of x because dy by dx is in terms of x. It is also best now to substitute the value of y, which is square root of a square minus x square. Y is square root of a square minus x square. So let us substitute not only dy by dx, but let's substitute even y. So we get x plus, now y is square root of a square minus x square from the given equation, and dy by dx is minus x divided by square root of a square minus x square. I hope that makes sense. So you substitute y, which is square root of a square minus x square, and you substitute dy by dx, which is minus x upon square root of a square minus x square. Okay, now this square root of a square minus x square and square root of a square minus x square will get cancelled, and you will be left with x. And if you notice here, it is plus and minus is minus, and you will be left with just x. And x minus x is 0, which is your right hand side. Okay, I hope that makes sense. So therefore, you can say that this differential equation, uh, this x plus y different dy by dx equal to 0 is true. Therefore, we can say that this y is equal to square root of a square minus x square. Therefore, we can say y is equal to square root of a square minus x square is a solution, of differential equation x plus y dy by dx is equal to 0. Okay, that's your final result. I hope it makes sense. Now let us quickly talk about this concept of types of solutions in differential equations. In differential equations, there are two types of solutions of differential equation. It can be either general solution or a particular solution. Let's see what's the difference between a general solution and a particular solution. General solution of differential equation is a solution where there is arbitrary constant, a solution that has, or, and when we say solution, first of all, when we say solution, a solution is nothing but a equation in x and y. Okay, a solution of a differential equation is nothing but an equation in x and y. Let's first remember that. And a general solution is a solution that contains arbitrary constant. Okay, and a particular solution is a solution with no arbitrary constant, no arbitrary constant. Okay, I hope that makes sense. So a solution of differential equation is an equation in x and y. Okay, and solution can be of two types. It can be a general solution. A general solution is a solution which involves one or more arbitrary constants, And a particular solution is a solution which doesn't have any arbitrary constant at all. So remember, particular solution doesn't have any arbitrary constants. Let's take an example. Y is equal to a sine x plus b cos x, so that a and b are nothing but arbitrary constants. Okay, so this solution, which is a equation in x and y, so this equation in x and y, a solution, this is a general solution. This is a general solution. Versus here, I don't have a and b. I just have fixed constants. I have 3 and I have 2. Okay, so that's fixed. So this is a particular solution. Particular solution. In simple words, if there are alphabets involved, A, B, C, M, P, Q, and so on, such a solution is a general solution. If there is number, fixed number values, such a solution is a particular solution. Okay. Also, from a previous note that we studied sometime before, remember that if it contains two arbitrary constants like this, A and B, we have to differentiate this two times. Okay, the number of arbitrary constants is always equal to the number of times you have to take derivative. So in this situation, if we wanted to convert this equation in x and y to a differential equation, we will have to differentiate two times. If there were three arbitrary constants, we would have differentiated three times and so on. Okay, so the number of arbitrary constants is always equal to the number of times we have to take derivative. All right, now that we understand the difference between general solution and the particular solution of a differential equation, let's look at a couple of multiple choice questions. Okay, here the first example says the number of arbitrary constants in the general solution. Remember, whenever you see the word general solution, remember that there are arbitrary constants always present in the general solution. Okay, so they say the number of arbitrary constants in the general solution of differential equation of the fourth order. So the differential equation is of the fourth order. That means there must have been four arbitrary constants, because only if there are four arbitrary constants, you will take derivative four times. Okay, because in this case there are two arbitrary constants, so you would have to take derivative two times. If there are three arbitrary constants, you will have to take derivative three times. So in this multiple choice question, since this is a fourth order differential equation, you would have to take derivative four times. And if you want to take derivative four times, there should be four arbitrary constants present in that equation of x and y. Okay, so in this case, the answer is four. I hope that explanation is clear. Next, the number of arbitrary constants in the particular solution. Whenever you see the word particular solution never have arbitrary constants. Okay, here we just saw particular solution will never have arbitrary constants, which is why the answer is zero, because since it's a particular solution, there will be no arbitrary constants present at all in a particular solution. I hope that explanation makes sense.